Evening, everybody. Welcome to our today's class. Today we are looking at a question under limits and continuity. And we are asked to evaluate lim x tends to 0 of sine into pi cos square x over x squared. As you know, just as I've taught in previous videos in our channel, anytime you have a limit involving sine ratio in trigonometry, the first thing that should come to mind is special limit under sine. So let's recall what that special limit says. It says when you have lim x tends to 0 of sine x over x, the value is always 1. So at what condition we made this limit to be 1? If and only if the value before the sign is also present in the denominator. That's the only condition you can have the limit of x tends to 0 of sine trig ratio to be 1. But if you look at the question, after the sign, what are we having? Pi cos square x. So for this limit to be 1, if I want to classify this whole thing as 1, the denominator should also be pi cos square x. But that is not the case at this point. So the first thing we do is to simplify this limit to ensure it is reducible to a certain level. So for me to do so, I will recall what cos square x says, that cos square x from trigonometric identity is simply 1 minus sine square x. That's the value of cos square x. So let's put it in place of cos square x. If that should happen, I'm going to have lim x tends to 0 of sine into pi brackets 1 minus sine square x now, which is standing in place of cos square x over x squared. So what we're going to do, we have two brackets here. This is the first and the second. So let's expound with pi to open this bracket. So I'm going to have lim x tends to 0 sine into pi minus pi sine square x over x squared. So that is clear. So pi times 1 will give us pi. Pi times sine square x will give us pi sine square x. So I see having the denominator as x squared. So what next? Recall that in calculus, whether it's integration or differentiation, pi is always 180. So let's recall from general trigonometric angles that sine 180 minus theta is simply sine theta. Sine is in second quadrant and the value of sine there is positive. So this pi, like I said, is 180. The whole of this now represents our theta. So when you have 180 minus theta, what you have is a sine theta. So what are we having from here? This will give us lim x tends to 0. I'm just left with sine pi sine square x over x squared. That's what we are left with. So let's simplify what we have here. Recall what we said earlier. For the limit to be 0, whatever I have before the sign should also be present in the denominator. That's the only condition. Our limit can be 1 according to special limit. So let's see how we can achieve that in this case. So what do I have before the sign is pi sine square x. So for this whole three can be 1, I should also have pi sine square x in the denominator. So to do so, I will have lim x tends to 0 sine pi sine square x. So I will introduce also pi sine square x. That's the little condition. It could be 1. But the question is, where am I bringing this one from? So I will multiply with equivalent number pi sine square x over our original x squared. So what next? So we cannot see that the whole of this now is 1, but we have sine square x here and x squared here. So we can also break it down. I'm going to have lim x tends to 0 of sine pi sine square x over pi sine square x times pi times sine x over x times sine x over x. So we can achieve our special limit in both cases. So sine x over x, when x tends to 0 is 1. The whole of this is 1, this is 1. So I just left with 1 times pi times 1 times 1. So if I multiply, I'm just left with pi. So the limit of this solution is simply pi. So if you like what you are watching, as always, subscribe, comment, and share our video. See you in our next class. Thank you. So let's solve the second question that says lim x tends to 0, 1 minus cos 4x over 1 minus cos 6x. So anytime you see a trig ratio in trigonometry, it's important we apply the concept of special limit of sign. So let's recall what the special limit says. It says lim x tends to 0 of sine x over x, the value is simply 1. So what's the lesson we are taking from here? So anytime you want to apply the special limit, what you have after the sign should also be at the denominator. So if here is x, here must be x. If here is 2x, here must be 3x. That's the only condition you can have 1. Okay, so as I've explained that in one of my videos also, you can check it in our channel. So let's solve the solution to the question. So if you look at this expression, there's no sign yet. What we have is cos 4x, but we can express cos in terms of sign through compound formula. Let's recall it that cos 2x, let's start with 2x. Cos 2x is simply 1 minus 2 sine square x. So what will now be cos 4x? So let's use 2x as a standard to judge 4x and 6x. Cos 4x will give us 1 minus 2 sine square 2x. And let's also judge cos 6x. So our cos 6x will be 1 minus 2 sine square 3x. So let's substitute the value of cos 4x and cos 3x into their various points. Here is cos 4x and here is cos 6. So if you substitute them, I'm going to have lim x tends to 0 into, I'm having 1 minus. So cos 4x is this. I'll substitute it here in place of cos 4x. So here will give us 1 into 1 minus 2 sine square 2x. The same is also true for the denominator. This is cos 6x. I will substitute it in place of cos 6x. I'm having 1 minus into 1 minus 2 sine square 3x. Bracket close. So let the minus sign open the bracket. I'm having lim x tends to 0 into, so here becomes 1 minus 1, minus into minus, that will give us plus 2 sine square 2x, bracket close, over the same thing to the denominator. I'm having 1 minus 1 plus 2 sine square 3x. So 1 minus 1 can cancel, 1 minus 1 can cancel. So what are we left with? We are left with lim x tends to 0 into 2 sine square 2x over 2 sine square 3x. So 2 can also cancel 2. So we are left with lim x tends to 0. Here is now sine square 2x over sine square 3x. Now, so you have square as a common factor for both the numerator and denominator. I can write this one that implies lim x tends to 0 into sine 2x over sine 3x, bracket close, or squared. So here we now have the sign we had initially under special limits. This sign here, that sine s over x, the result is 1. But you look here, we're having sine 2x over sine 3x. So that means I can divide through by x to obtain the special limit. So I'm having lim x tends to 0 into sine 2x over x over sine 3x over x, bracket open close, or squared. So remember what we said earlier, what you have after the sign should also be present in the denominator. That's the only condition we could have 1 as our answer. But if you look here, we're having 2x, but here is simply just 2. So how do we make here 2x? That means I will multiply both the numerator and denominator by 2. So if that should happen, we're going to have lim x tends to 0 into 2 sine 2x over 2x. Then the denominator, I will do the same, 3 sine 3x over 3x, or bracket open close, squared. So from special limit now, the whole of this is 1, the whole of this is 1. So we are just left with 2 times of 1 over 3 times of 1, or squared. That will give us 2 over 3, or squared. So the square here is governing both 2 and 3. So if I square 2, that will give us 4. If I square 3, that will give us 9. So our answer is simply 4 over 9. So if you have any question regarding what I've just solved, you can always post it on the comment section wherever that is not clear to you. And if you have not subscribed, please do so. If you subscribe, please recommend to others. Thank you.